Okay, first of all good performance tests should simulate as close as possible the production environment. In terms of hardware, so the same CPU, RAM, storage. Usually production machines are quite powerful. Powerful means costly. So there is a good chance that you will not be able to buy a copy of production environment just for performance tests. On the other hand, you might face the paradox that your test environment is faster than production. Simply because you are using SSD drives, and on production you are forced to use some old network attached storage, which latency is just horrible. Anyone experience this kind of situation? Yeah, so it's not only me. That's good. Okay, the same software, so the same version of operation system, virtualization, database, etc., etc. And sometimes this could be hard to achieve because of some crazy licensing policy. You cannot upgrade to the newest version because of some security reason, etc., etc. Then the load. So how to simulate real production application daily load. Obviously, if you want to test Facebook-like application, you will not launch billions of users. You need some clever way to simulate this. Usually, you're in the 99th percentile of application with some reasonable number of users. And even then, you don't have to launch exactly the same number of users to get some knowledge about performance of your system. Isolation. Definitely, you don't want any interference with your performance tests. So if you are forced to use the same environment as QA testers, then I feel sorry for you. I've been there, it's nightmare. Yeah. Make sure that nobody is running some heavy cron jobs while you are testing the app, because even without this, it will be really hard to analyze potential bottlenecks. Try to automate things and run your tests during the night when nobody is using the environment, so that you will get results the next day, or very nice message about the error, and you are 1 day behind, or another day behind. Or change your strategy completely and run performance tests on production. I strongly don't recommend this approach, but who knows? Maybe you're lucky enough, and in your case, it won't be such a bad idea. There are some systems that's actually quite nice idea. Just remember to clean test data after you're done. So, besides dedicated infrastructure, you will need monitoring, very good monitoring of your host, databases, messages, bus application. Basically, everything must be connected to monitoring. And for that, I could recommend great monitoring as a service like Datadog. Very nice piece of software, easy to integrate, easy to configure. You don't need a whole DevOps team, but if you have DevOps team, then you could switch to Prometheus plus Grafana. Great tandem. Prometheus for storing time series data, and Grafana for visualizing them in a modern, or not necessarily modern fashion, but still, it's readable. Previously, we used, I don't see this. Anyway, previously, we used Influx for storing data. The architecture of Influx is quite different, because Influx, you need to push data to Influx. And in case of Prometheus, Prometheus itself will pull data from your metrics endpoints from your application. And in our case, such approach was simply better. Okay, when you can say that you have a good monitoring, you need to have this nice select button where you can easily switch between different environments. So test, dev, prod, whatever, and have exactly the same metrics for all these environments. And then you need to monitor all levels of abstractions, and we have quite a lot of them nowadays. At the bottom, we have JVM metrics, so things like GC pauses, memory consumption, number of threads, etc. But at some point, you will need to provide some business metrics from your application level. Things like, we lost it again, database queries response times, your HTTP endpoints response time, etc. But having only business metrics is useless, because it will be really hard to say why something is slow or why something is fast without JVM metrics. Then there is Docker and some Docker container orchestrator like DCOS, Kubernetes, or whatever. And usually those two will provide you some sort of monitoring. So I hope that you get the pattern that with ping or velvet color, there are layers that you definitely need to monitor, and with green color, let's say not necessary. Still nice to have it, but not necessary. At some point, you will hit the host limit, so it's useful to have metrics from bare metal, things like which application is consuming the CPU the most, which application shouldn't be deployed together on the same host. And because hosts are created right now from the cloud, you need to also monitor the cloud. Who is using AWS? Probably a lot of you. Yeah, so if you're using AWS, there are these T machines. Really, I mean, quite powerful option and quite cheap, but there is one gotcha. If you consume all your CPU credits on such machine, the CPU power will be limited to something really, really slow. But on your host level metrics, it will look like you are consuming 25% of the CPU, which is quite low. But in fact, you are consuming 100% of the CPU because of the consumed CPU credits. And this is confusing us. Let's say it's really confusing. So that's why, once again, you need to monitor all levels of abstractions. And one more thing about monitoring. I recommend to start with monitoring since day one in the project, or almost day one in the project, or before deploying anything on production. Why? At the beginning, you will be overwhelmed with the amount of data, different kind of charts, metrics, data to analyze, and you need to slowly learn how to use these tools, learn what are the healthy application trends. For example, here is a very healthy application trend, because I know that each 15 minutes I need to start some small job and I will consume more CPU. What happened here? It's something strange. Maybe it was only restart, maybe something that I should investigate more, but still, if you train your brain to know what are the healthy application patterns, then you will see problems much earlier. And if you learn all this stuff, when you face some problems on production, you will not jump from idea to idea, from metric to explain what is going on. You will know exactly what should be checked first, and then. And as my friend used to say, some people observe the sky and see some patterns there, or maybe the answer also. And we need to do the same thing, only by observing hundreds of charts on just 2 displays. So kind of sad, but true. Then logging, a lot of logging, but I would say intelligent logging. So things like, once again, database queries response time, HTTP endpoints response time, correlation ID, especially in case of microservices architecture, dynamic log configuration so that you can change the log level without restarting the app, for example, via JMX access, and similar stuff. For that, I could of course recommend a LK stack, but since few projects we are using Greylog, and in my opinion, Greylog is much better. And why? For example, you can configure streams. You can divide your logs by environment and by application, and then set up different retention policy. For example, you can keep your logs from production for half a year, and from dev environment only for 2 weeks. Alerts, the support for alerts is definitely better than in LAK, and you will need them especially on production. Dashboards. Yeah, usually I'm starting with dashboards similar to this one, where I have all my warnings, errors, and all logs. And the moment in time when application was restarted, I'm not sure if you can spot this, but you can clearly see that after restart, we are generating a lot of errors. So yeah, we mess up with this deploy. Fortunately, it's only dev environment, so we need to fix it. And someone could ask, okay, this is nice, but how it will help me with my performance test? Trust me, you will need logs later to analyze if your application is behaving correctly. But still, you can observe some trends. Usually, a healthy application should produce more or less the same amount of logs in some period of time. And here you can observe performance degradation because less and less logs is generated. Of course, the root reason for this could be something completely different, but still it's nice to have such information. Okay, then profiling. Usually I'm starting with Java Visual VM. Very nice tool, built-in into JDK, easy to learn, easy to use. You just need to expose JMX port and connect to your application on production and get some basic data about your JVM behavior. There is a sampler which is not so detailed as Profiler, but still it will give you information like which method is using the CPU the most, or similar to this one. There are some plugins, for example, for visualizing GC. Yeah, it's kind of fun to watch this in real time, especially from production. And when JVisual VM is not enough for you, I could recommend Java Mission Control and Flight Recorder. In my opinion, and not only my opinion, this is the best profiler that currently exists for JVM application. There is one gotcha. You can use it for free since JDK 11. Before JDK 11, you can use it for free only for test and dev environment, and for production, you should buy a license. So yeah, that might be a problem. But right now, this is the best profiler that exists. And similar to monitoring at the beginning, the amount of data about your JVM is like, whoa, my brain will explode. But don't worry, slowly you will learn how to use this tool. Usually I'm starting with some hot methods or hot threads and expanding the tree and looking for something interesting. And yeah, I suppose this is a good way to start. There is one more profiler. From good sources, I know it's worth to try it, Honest Profiler, but honestly, I never use it. It's totally for free, and it will not lie to you about your JVM, like most of existing profilers. So, okay, someone could ask, why do I need so many data? And one of the aims of performance tests is to find potential bottlenecks. And without data, you're just a person with an opinion. Nothing more, trust me. And usually I'm dedicating this slide to my former technical leader, which pasted this guy so many times on our Slack channel that I started to hate him. When I close my eyes, I see this guy's face, really. I even start to use this sentence in my personal life, let's say during some difficult conversations with my wife. Yeah, I'm not so sure if that... Yeah, I'm not so sure if that was a good idea, because who would predict that she will use it against me? And not all my ideas, beliefs are based on some strong data. But anyway, this is the first thing to remember after this talk. Any questions to that part? Okay. So when you are a senior developer, especially when you are a senior developer, you can start to feeling something inside of you which we could call performance intuition. So someone is asking you for help. Look, we have problems with performance. And you are just saying, oh, it's definitely database. Oh, you need to change your thread configuration, or your dispatcher configuration, or whatever. No, this is completely wrong. Usually, after such tip, the performance will be the same, and in worst case, it will be even worse. And the algorithm is pretty simple. First, collect the data based on your monitoring, profiling, and logging. Find the bottleneck based on that data. Fix the bottleneck, but fix only one thing at a time. Do not fix all possible bottlenecks because you will be lost. Then collect the data again and check your assumption. Is it better? How much is it better? Maybe it's worse. And repeat it. Unfortunately, even if you are aware of this procedure, the temptation to skip step number 1 or even step number 4 is so intensive that you will do it. Sooner or later, you will do it, I will do it, everybody will do it. And why it is so hard to fight with your intuition and actually how your brain is working under the hood, I could recommend a great book of Daniel Kahneman, Thinking Fast and Slow, where you could find answers for questions like that, and many, many more interesting facts about the brain. Okay, another problem with performance tests is math. Because there is an old saying, lies, damn lies, and statistics. And believe me, this is so true, and I was crying because of this so many times. And of course, this is the second thing to remember after this talk. Maybe not only this one sentence, but the whole slide. So let's say that you have a chart with response times like on the slide. And clearly, there's something wrong with the last response. So if you use only arithmetic mean, basically arithmetic mean is useless. It's not possible to spot a problem using only arithmetic mean. Median, even more useless. Standard deviation, also useless. Standard deviation is okay only for normal distribution. And in case of IT systems, normal distribution is not so common. Actually, I would say it's really, really rare to have it. Another example of statistic nature could be Anscombe's quartet, which determines 4 different data sets with nearly identical statistical properties, yet when represented as a graph, it looks completely differently. So imagine that those are your performance characteristics, completely different graphs, and the numbers are the same. Crazy. So what should we use then? And my answer is percentiles. In my opinion, this is the best metrics to get the overall view of your performance characteristic of your application. But be careful again. And check your percentiles implementation, because it could use mean and standard deviation, which of course makes them useless as well. Another example of percentiles problem could be drop wizard metrics library. Who is using drop wizard metrics? Yeah, I have a bad news for you. You should probably get rid of it. Or maybe you are perfectly aware how it is working under the hood. So, first, we will do a small experiment. We will generate a lot of samples that will indicate a normal application behavior. So values from 0 to 100. Then 100 standard peaks with value equal to 1,000 and few really high peaks with values equal to 10,000. Combine them together and generate 3 times histogram using drop wizard metrics. And surprise, each iteration completely different results. First iteration, 99 percentile is equal to 98, max value 1,000. Second iteration, 99 percentile, 98, max value 99. Great results. You have no clue that you have performance hiccups. And third iteration, 99 percentile, 99, and max value 10,000. So what is going on? Why drop wizard metrics is lying to us? Actually, everything is working as expected, because drop wizard metrics is using something called exponentially decaying reservoir, which is a very fancy name for a very fancy algorithm, but using very simple words, from your set of samples, it will randomly choose some subset of samples and calculate percentiles based on that subset. So, if you're lucky enough, you will get good results. And if you are not lucky, you will get correct results. Okay, great, so I just need to change this reservoir implementation. Yeah, but the next one is also using random. There are 2 more, sliding time window and sliding window. Those 2 will give you correct numbers, but they will show you something completely different. In case of sliding window equal 4, the algorithm will take first 4 samples, calculate percentiles for those samples, then next 4 and the next, etc. And in, for example, the third iteration, 95th percentile is equal to 50, which is correct, but I would like to know what is the 95th percentile for the whole test and for all my samples. And I cannot get this value from drop wizard metrics library. I mean, I can, but I never know if it's correct or not. And in this case, 95th percentile for this set of samples is 40. So it seems like calculating percentiles should be a trivial task. It is, but if you need to provide dynamic range of values, high precision, and slow memory footprint, as usual in IT, you cannot get all 3 properties at the same time. Fortunately, there is a tool that chooses a reasonable compromise for this problem. HDR histogram will provide you dynamic range of values, small memory footprint, and reasonable precision. So for the same set of samples, I launched against HDR histograms, and now percentiles are correct, no randoms, but there is small cost, and the cost is precision. Here, max value is 16,000, and we know that the max value should be 10,000 because that was the highest peak. Actually, there is a small bug on this slide because I should scale those values from nanoseconds to milliseconds, and the difference will be much smaller because the buckets will be different, but I leave it as it is just to show you what is the cost. Still, for calculating percentiles, HDA histograms is the correct choice. Yeah, so which percentile should I be worried about? 95th, 99th, 39th? Who will vote for 95th? 99. Okay, you don't want to vote, I get it. Actually, the answer is all of them. Why? Because there is something called coordinated emission problem. And this is the third and the last thing to remember after this talk. Yeah, almost 20 minutes and we are done. Nice. Stay a little bit longer, there will be more. Anyway, what is this coordinated emission problem? This term was first introduced by WlkTo. By the way, WlkTo is my performance guru. I really recommend to watch his videos, presentations. This guy really knows things, so definitely remember this name. So I will explain this problem using very simple example. We have 60 seconds for the whole test, and each second we will generate one request and wait for the response. And responses, I'm not sure if you can see this, but they're pretty fast. Usually you will get them after 1 second or 1 millisecond, or it doesn't matter, just a matter of scale. But after 31st request, we need to brutally kill the application. So system exit 0, kill -9, things like that, to simulate very long GC pause or some problems with application under the heavy load. And this way, we will not get the response for the 31st request, but since there is 30 seconds to the end of the test, most of the performance tools will assume that this request took 30 seconds and ended with some errors. So let's calculate percentiles for such example. 19th percentile 1, 95th percentile 1, and performance degradation since 99th percentile. Do you see a problem here? Because there is something smelly. Okay, our application was dead for half of the test, and 95th percentile is 1. Ooh, something is not right. Let's look like how it will look like in case of 1001 sample. In this case, 99th percentile 1, 3 nines 1, and performance degradation since 4 nines. So whoa, once again, maybe percentiles is not such a great metrics after all. No, in this case, the problem is with testing methodology. So in real life, after 31st request, we will not wait for the response. We will generate another request exactly after 1 second, and then another and another. And this way, we have half of the samples when the application was healthy, and half of the samples when the application was dead. And percentiles are now completely different. Number 50 is 1, which is correct, because half of the test application was healthy, and then performance degradation since 17th percentile. And those are correct percentiles. The previous one are fake percentiles or percentiles with coordinated emission problem. I suppose this graph shows pretty well why it is problematic. Let's say that this orange line is your SLA contract. If you are able to deliver application with percentile histogram under this line, you will get a lot of money. I mean, a lot. And you check your performance, the red line, and you are pretty happy with the numbers. But your customer also checked the performance using different tools, different methodology, blue line. And clearly you can say goodbye to your a lot of money contract, or ask for more time and fix your implementation. Fortunately, you can validate your percentiles using simple math. First, you need to gather total time of the test, maximum request time, and for example, we want to validate 99th percentile, which is 1. So first, we need to calculate what is the percentage for maximum request. And in our case, is 50% because 30 divided by 60, you see the pattern. Then expected time in percentage for the 99th percentile. Because this is actually percentile number 100, so -1, this is expected time for 99th percentile. And 39% from 60 is 29.4, which is a little bit different than 1. And usually, the difference is huge, like hundreds of thousands of times. Right now, the difference is not so huge, but still you can see that you have coordinated emission problem. You can also observe the graph. Usually, a healthy histogram will grow with this nice blue curve. And in case of percentiles histogram with coordinated emission problem, you will observe this peak near the 99-something percentile, red line. Okay, any questions to that part? No question. So is there a tool that I could use that don't have this problem? Yes, there is. It's WlkTo. Guess who is the author? Of course, WlkTo. And guess who is the author of HDR histograms? So this tool will provide you constant throughput load, accurate latency details, LUA API, and no coordinate omission problem. Am I using it? No, mostly. Why? Like most of you, my performance tests testing some business flow. So I'm forced to wait for the response before I generate another request. And you cannot check out the shopping cart and then add something to your shopping cart. Simple as that. That's why I, like most of you, we are all doomed to the coordinate omission problem. So the only thing what we can do is to first be aware of it and then try to minimize this effect. Still, WlkTo is a very nice tool for testing totally stateless APIs. So remember the name. And I will show you how to minimize this effect using Gatling. And yeah, the last problem with performance tests are tests themselves. In the sense that someone needs to write them, support them. Usually you have deadlines for features, not for tests. Sometimes it is not so obvious why should I test in case of performance tests. So obviously, not all corner cases, not all functionalities. I would say you need to choose most business valuable path. So for example, in case of e-commerce system, you would probably want to check how many users can buy something in case of Black Friday, which is today. Or how fast is your search engine functionality. So things like that. And now it's time for tools. So my first idea was that I will somehow gather existing performance tool and then compare them together, but it's impossible task. It's simply too many of them, and such comparison will be very soon outdated. So I will show you which tools I'm using. Actually, I showed a few examples already, but now I will focus more on different tools. What are the pros and cons? What you should expect for good performance tool? And I hope that it will help you to validate your current toolbox. And yeah, we'll see how it goes. So my weapon of choice in case of performance tests is black screen. No, it's Gatling. So why? Because it's based on non-blockus, asynchronous stacks, Scala Akaneti. Each virtual user interaction is represented as a separate actor. And thanks to this, I could generate huge load even from my local machine. On the other hand, in case of, for example, JMeter, the only reasonable, in my opinion, of course, alternative to Gatling, each virtual user is represented as a separate thread. And to be honest, you can generate pretty decent load using JMeter as well, but it will cost you more RAM and more CPU. Should I wait or continue? So time for questions.
Can you provide some comparison between JMeter metrics, well, JMeter, CPU and memory consumption versus Gatling?
There is a nice article on DZON about this. So I recommend to check DZON and see Gatling versus JMeter or something like that.
Yeah, there's a lot on the internet, but from the top of your mind. 3 times, 5 times, 100 times.
No, the difference is much smaller. But I will show you why Gatling is still better.
Hi, my name is I have a question regarding profiler tools. So you mentioned that you're using Visual VM, but in one of my projects, we had this like really heavy Scala application in which when you try to attach with Gem export, Visual VM just hangs. And the actual kind of alternative was only gprofiler, and I'm very encouraging to use in my current place of work this gprofiler. So
I'm not sure if I understand you correctly, but
did you experience such problem with standard Visual VM, or you're just like researching dumps?
Usually Visual VM is like good for a start. But if you need to launch real profiler, then jump to Java Mission Control. JVisual VM is like, okay, there is something wrong. I simply connect to my application and check what's going on. And if I'm not able to answer where is the problem, then I'm starting with a real profiler. Okay. I see my presentation here, so. Okay, so why Gatling? You can use Scala for your performance tests. How cool is that? No more JMeter XMLs. Don't get me wrong, I was using this tool for a long time, and at the end I quite like it. Yeah, the UI is horrible, but I'm using Linux, so I don't care. But the worst thing are those XML files. Good luck with versioning it or review it or whatever. And here you can use normal programming language. Maybe in case of Scala, normal is not the best word, but still you can refactor it, reuse it, everything. Who is using Scala here? Who would like to use Scala? So I suppose this is a good way to introduce Scala into your ecosystem. You don't have to use it for some business code. You just need to write few performance tests and then slowly move to business code. Just saying. You can use Gatling even if you are not so familiar with Scala because it's DSL, it's so easy, so readable. I will show you later. Yes, there is a recorder so that you can generate some tests based on your HTTP traffic, but please don't use it. And I know that you will use it anyway. Just remember that those tests are generated, and at some point you will need to refactor them. Math is good. Very nice visual reports out of the box. And you can use Gatling not only for performance tests, but also for integration tests. And actually, usually I'm starting with few really simple integration tests. And then transition from integration to performance tests is really easy. And yeah, Gatling is not resistant to coordinate admission problem. Okay, and here's your first Gatling scenario. I'm not sure if you can see it, but basically the idea behind the DSL and what you should expect from your performance tool is that your tests will be readable almost as a normal sentences. So execute HTTP, get root, pause for 7 seconds, set up first scenario, inject at once user, etc., etc. So this readability is really nice in Gatling DSL. And a little bit more complex scenario, it looks okay, but once again, very simple techniques like method extraction, and you can improve the readability. And then divide complex business flow to smaller one and combine them together and create more and more complex business flow. And modularity is really important feature of your performance tool. And from my experience, you will never get a good level of modularity if you're using JSON or XML or whatever. You will get good level of modularity only when you are using programming language. Not necessarily Scala. It could be something different, but only programming language will provide you good level of modularity, and you need it if you want to keep your test up to date. Trust me. Okay, more on DSL. So each response should be somehow validated, and you can validate the status like on the slide. You can validate the payload using some regular expression. Basically, you can validate everything in the payload using regular expression, but I would recommend to use some built-in support for parsing JSON, XMLs, and even CSS selectors for HTML response. I will not waste your time and explain how it's working under the hood. You can check it in documentation. What is worth to mention here is that you can save some part of the response in the virtual user session and use it later, thanks to Gatling expression language, in next request. This $sign and curly bracket. And this way you could generate really complex business flows. Loops, most of performance tools will provide you some support for loops. Here is basic repeat loop. There is for each, during, as long as, forever, and you probably can't see it, but anyway, details in documentation. There is something called polling, concept similar to loop, but in this case, your scenario can move forward and polling will be executed in background. Conditions, so if, classic if else, switch, random switch, etc. Yes, similar to production code, too many ifs and too many conditions is not the best idea, so keep your test rather easy and straightforward. Error management, Trimax, very useful functionality. Let's say that you want to send money from Alice to Bob, but communication between them is completely asynchronous, for example, via Kafka. So if you check if money was received right after sending money, this check could fail, simply because message from Kafka was not consumed yet. But it will be eventually, so this check will pass probably after a few retries. And yes, you could put a pause here and do it in the loop, but in case of performance tests, pauses is not a good idea because you would like to put maximum pressure on your system under test, and with pauses it will be rather hard. Okay, and this brings us to scenario setup, where you can define things like how many users should be started at once, how many users should be started using some ramp over time, maximum duration of the tests, and yeah, this is for me. This is the place where you can minimize coordinate emission problem. So let's say you have a business flow and you can repeat it 1,000 times. No, that's the wrong way. You have business flow, you should launch 1,000 users here. And this way you will minimize the coordinate emission problem to hopefully some reasonable level. You can specify some global assertions for the all response. Let's say you would like to have response time less than 50 milliseconds and failed request percentage equals 0. Yeah, about that I will be very careful because I suppose in some cases some failed percentage is okay, simply because in case of performance tests you should probably expect timeouts, and timeouts are not errors. You probably put too many load to your application, so up to some percent is okay. What is the value? I don't know. In my case it's still 0, so throttling, very useful feature. In this case, your scenario will reach 100 requests per second within 30-second ramp, hold it for 1 minute, then jump to 50 requests per second and hold it for 2 hours. And this is especially useful in case of soak test, so very, very long performance test, where you want to determine if your system can sustain continuous expected load. Feeders, you probably will need to provide some random or unique data for your business flows, and for that you could use feeders. And feeder is just a simple map, key value map, that's it. Which values could be accessed, once again, thanks to Gatling expression language. You can create feeders manually, like on the slide, or use some built-in support for parsing JSON, JDBC, CSV files, etc. And this way provide data for your business flow tests. Yeah, reporting. So very nice visual reports. This is what you will get on the console, but you will also get very nice HTML report like this. With all the necessary performance indicators, so mean, max, standard deviation, percentiles, of course, very nice graphs with response time distribution, response time percentiles over time, requests per second, etc., etc. And this is generated for all your actions. Let's say you want to check slowest action for 95th percentile, which is search for. And now you will get all the same details only for this one action. And this is HTML, so it's really easy to save it, and then you have the history of all your tests. Okay, there is more, but the purpose of this presentation is not to show all aspects of Gatling. So just remember that you can create custom validators. In case of HTTP, there is an SSL support. You can simulate server-send event. There is a basic cookie support. You can use Gatling for testing WebSockets. And I tried different tools for testing WebSockets, and it was pure nightmare. And here the support is pretty decent. It's not so nice like in case of HTTP communication, but still it's worth to try it. You can use Gatling for testing JMS system. Actually, the whole architecture is quite pluginable, so you can use community plugin for testing Cassandra, Kafka, RabbitMQ, etc. And recently, my friend created a plugin for testing 0MQ message key. So yeah, I think that this is quite important and proves that the project is not dead and the community is quite active. And yeah, as I said, using Gatling, you can generate huge load even from a single machine. But right now, probably your application is deployed on some crazy cluster system. So single machine, it won't be enough to put good pressure for such system. So what you want, instead of this, is something like this. And how to get it? Yes, you can do this manually. You just need to start a few nodes, then upload the test code to these nodes, then start the test, then gather the results, and then generate reports based on that results. And it sounds like a waste of time, because it is. You can use existing services for that, like Gatling Frontline or Fluid.io. And yes, those services are not for free, but I suppose your time is pretty expensive as well. So I recommend to put more focus on tests themselves, not on how to launch them. Here's a screenshot from Fluid.io where I have over 411 performance tests. And I'm not sure if you can see this, but right now we are testing 5 C4 large machines. I generated 36,000 users, and the average response time is really, really bad. Some different tests, this time 3 times M4 2X large machine, 38,000 users, and average response time is better. Still not good, but definitely better. And imagine that you will need to do this manually. Even if you have some script, it will be really, really hard task to do. And here, I just need to upload my test code, then select how many nodes should generate the load, and wait for the results. That's it. In case of Fluid.io, you can use JMeter as well, and Selenium, although it's hard to me to imagine performance tests in Selenium, but still you can. But you are forced to use AWS. In case of Gatling Frontline, you are forced to use Gatling, obviously, but you can use different cloud providers. Yeah, last idea, although I'm not sure if I should even show it to you, but it's too late anyway. So imagine the situation that just before my presentation on some conference, a rockstar developer said that performance tests are useless. They are so error-prone, so expensive that you shouldn't even bother. And I was like, what did you do this to me, my friend? Now no one will come to my presentation, and I was pretty upset. But then I started to thinking, and because I'm a professional consultant, the answer to this question is it depends. Depends on what? On context. So this guy context was that they started a startup company with some web application, and they have really great detailed monitoring. So after they deployed, they could easily spot a performance problem because, thanks to this great monitoring, and then decide what to do with it. So they could, for example, revert deploy, fix the deploy, or simply ignore it. Because in case of startups, I suppose a few milliseconds this way or another might not be so important like new features. And I totally agree with such approach, to choose the optimal solution for your case. But in some applications, I think in many of them, performance problems are business problems. So ignoring performance tests by default is not a good way, in my opinion. And I hope that you get the overall idea behind this slide, that in case of performance tests, you should question everything and everybody, including yourself, me, and this whole presentation. I would be more than happy if you ask me after this talk or tell to me that I said something stupid or that I have an error on my slide, because this way I could learn something new. And that was the last idea I wanted to share. Thank you very much. If you have any questions whatsoever, just wait for the mic.
Okay, another question. You showed this console single report from the Gatling execution, which was like pretty with max, mean, and average statistics. Is it configurable?
Yeah. You can, for example, define which percentiles you are interested the most. Because right now, I think, yeah, you have 95th, 99th. So if you need 97th, then that's not a problem.
is it JSON configurable or somewhere? If I have just this like console application without front-end aggregator?
I mean, you will get it either way. When you run Gatling tests, you will get information on console and also in your target and catalog with all this HTML stuff. So,
thanks.
Hello, thank you so much for your speech. So I have a small question. You said about isolation in terms of environment, but what if your application rely on some third parties? How could you, so any advices how to isolate from third parties in this case and test your application?
to be honest, there are two options. You need to create environment with copy of everything, or you will create mocks. But this way you will test only, yeah, I know what you think, but that's the only reasonable way.
Hi. So you were talking a bit about how it's hard to make tests for these large-scale cloud environments, and you have to scale it. What if, for example, our goal would be to monitor performance degradation over several versions, and if we were just to downscale the actual test environment and run a single instance to generate load? Any potential things to be mindful about in that scenario?
Could you rephrase the question? Because you are asking if I could test my application using smaller environment? Or?
No, I'm thinking, yes. For example, instead of, so say we have like a multi-server cloud environment.
Okay.
And we replicate it internally in a cluster with just making all the nodes like significantly tinier.
Yep.
So instead of, say, like 20 cores, you get 2 cores.
Yeah.
And then instead of having to need like a cluster of machines to generate load against it, we just use a single machine. That way we don't have to like scale out the slave machines that run the test against the environment. So that, and then in this case, so we keep the test environment always the same, and then test multiple versions against it to see if it's like better or worse than before.
Yeah, it was on the first slide. It's like very rare that you will have exact copy of your production. So yeah, it's quite common to have less powerful machines, for example, not 64 cores, but just 4. That's okay. But if you have some scale, for example, 20 machines doing the same, then you should use some scale also on your test environment and have only 2 machines, but still you will then test the load balancer, etc., and all the application layers. So sometimes your application will behave completely differently when it is scaled and when it's launched on a single node. Yeah, but I think the answer is it depends how much money you have. Okay, any questions?
Hello, thank you so much for your speech. And I have a question about weight of one single thread in Gatling. We noticed that one thread in Gmeter is so heavy and in meaning of CPU or memory it costs so much. What about Gatling?
As I said,
the same, yes?
No, there is no threads. You have actors. Each virtual user is a separate actor. Let's say separate actor. And actors consume threads in a slightly different manner. That's why, in most cases, you will generate more load using Gatling. It depends on your configuration and your tests, but in most cases, it's...
Can I ask, actors, it's something like actors in Erlang?
Yeah, yeah.
Wow, so it's completely isolated.
I mean, I'm not so specialist. It's actors from Akka stack. So I think that they implement it in a similar way. I'm not sure about the details.
Okay, I understand what I mean. And one more question, please, about Greylog. You just mentioned about it, and we noticed also trouble with Greylog about Java exception handling. So Greylog parse stack trace in very strange way. Did you have some trouble? How you handle it?
Actually, I have a good DevOps guy, and I just say, please fix it, and he fixed it. So I don't know the details, but I remember that we have a similar problem with exceptions.
But you fix it?
Yeah, somehow.
Can we maybe connect after the speech?
Sure, no problem.
I need this decision. Okay, thank you.
Okay, any question? So you are free to go for lunch. Thanks.